This is Bob Capetta from the University of Illinois at Chicago, and this is the Fundamental Theorem of Calculus and U Substitution Part 2. Our first example is the integral of cotangent. Now, you should know the derivatives of all 6 trig functions, and the derivative of cotangent is minus cosecant squared, but that doesn't really help us here. What's better is knowing that cotangent is cosine x over sine x. That will enable us to do U substitution. But when we see that, we ask ourselves, what should U be? Well, if U is sine x, the derivative is cosine x. And we're always looking for a multiple of that derivative in the numerator, and we have it. So indeed, we're going to let U equal sine x. And then the derivative with respect to x of U is the derivative with respect to x of sine x. So du dx is cosine x. With my strategy, I want to solve for dx. So du is cos x dx, du divided by cos x is dx. So we're going to replace this dx with du divided by cos x. We're going to replace this sine x with u, and you'll notice the cos x's will cancel. So when the cosine x's cancel, we just get integral of 1 over u du, which of course is the natural log of the absolute value of u, plus c. But what is u? U is sine x. And our final answer will be natural log of the absolute value of sine x plus c. Our next example is the integral of x plus 3 over x squared plus 6x plus 13 to the 7th power. And if you look at this denominator, x squared plus 6x plus 13 to the 7th power, what do we want u to be? Well, if we let it equal x squared plus 6x plus 13, you'll see its derivative, 2x plus 6, has some multiple upstairs. That's our strategy. So indeed, there's u. Take the derivative with respect to x of u and the derivative with respect to x of that, x squared plus 6x plus 13. So we get du dx is 2x plus 6. I want to solve for dx, so du is 2x plus 6 dx. Du divided by 2x plus 6 will be dx. But I need the x plus 3 to cancel. How is that going to work? Divide the 2 out here. That will become du divided by 2 times quantity x plus 3. And that's going to cancel the x plus 3 in the numerator. So the bottom is going to become u to the 7th power. Dx is du divided by 2 times x plus 3, and that will cancel the x plus 3 in that numerator. When the x plus 3 goes away, this 2 downstairs, there's a 1 upstairs, so 1/2 comes out in front. 1/2, integral of 1 over u to the 7th du. 1 over u to the 7th is u to the negative 7. And then we can think of our power rule. Right? The integral of x to the n is x to the n plus 1 over n plus 1. If we kick up negative 7 by 1, that'll be u to the negative 7 plus 1, u to the negative 6 over negative 6. So this is what we have, and there's our u. And indeed, using our power rule, x to the n plus 1 over n plus 1, u to the negative 6 over negative 6. 2 times negative 6, negative 12. The fraction here will be negative 1/12 of u to the negative 6. But what does u to the negative 6 mean? It means 1 over u to the 6th. And then we'll make the substitution in for u. U is x squared plus 6x plus 13. So we get negative 1 over 12 times 1 over x squared plus 6x plus 13 to the 6th power. And just making this a little cleaner, multiplying the fractions on top, negative 1 times 1 is negative 1. 12 times all this on the bottom is all on the bottom. And that's our answer to that question. Our next example is the integral from 0 to 2 of e to the 5x dx. U will be 5x. The derivative of 5x is 5. Is a multiple of 5 in the numerator? Of course, 1 is a multiple of 5. That works. But we're also going to have to change the endpoints. So we're going to start by saying u is 5x. The derivative with respect to x of u is the derivative with respect to x of 5x. The derivative with respect to x of u is du dx. Derivative with respect to x of 5x is 5. So du is 5 dx, and solving for dx, du divided by 5 becomes dx. So this will be e to the u, and this will be du over 5, but we have to change the endpoints. If x is 0, that's what that means. X is 0 because it's dx, and x is 2 because it's dx. What will u be? Well, if x is 0, u is 5 times 0, or 0. And if x is 2, u is 5 times 2, which is going to give me 10. So my lower endpoint is 0, my upper endpoint is 10 with u's. So we'll rewrite this as u goes from 0 to 10. is going to be our strategy. E to the u, and then dx is du over 5. So we'll see how that works. U goes from 0 to 10, e to the u, du over 5. Well, du over 5 is essentially 1/5, so we can pull a 1/5 in front of this integral. So we'll get 1/5 integral as u goes from 0 to 10 of e to the u du. You need to remember that the derivative of e to the x is e to the x, so the integral of e to the x is e to the x. Integral of e to the u with respect to u is e to the u. Antiderivative of e to the u evaluated from 0 to 10 multiplied by 1/5 using our fundamental theorem of calculus. Plugging 10 in for u, e to the 10th minus e to the 0, quantity multiplied by 1/5. So we get 1/5 e to the 10 minus e to the 0, and remember that e to the 0 is just 1. Anything to the 0 power other than 0 will give us 1. So 1/5 e to the 10th minus 1 is good enough for that problem. Our next example is the integral from 0 to the square root of pi of 3x times sine x squared dx. This time we are going to let u equal x squared. Its derivative is 2x, and a multiple of that is in the numerator. So that should enable us to work the problem. Don't forget to change the endpoints. We'll have to do that too. All right. If u is x squared, we take the derivative with respect to x of u as the derivative with respect to x of x squared. Du dx is 2x, du is 2x dx, du divided by 2x is dx. This will become 3x. Sine u dx is du divided by 2x. But we also need to change the endpoints. If x is 0, what is u? If x is root pi, what is u? Well, x is 0. U is x squared, so 0 squared is 0. And if x is root pi squared is pi. So our lower endpoint is 0, and our upper endpoint is going to be pi. So again, the new endpoints are u is 0, u is pi, 3x sine of u, dx is du over 2x. X's cancel, 3/2 comes out front, integral of sine u du. Now, what is the integral of sine u? That's our question here. And let's take a look at some of our basic trig functions to help us identify what that's going to be. We know the derivative of sine x is cos x, so the antiderivative or integral of cos x dx is sine x plus c. But I want to get an integral of sine of u, sine of x. What else do we have? The derivative of cos x is minus sine x. So that the integral of minus sine x would have to be cos x. If the integral of minus sine x is cos x, the integral of sine x would have to be minus cos x, just kind of multiplying both sides by -1. So we have here is the integral from 0 to pi of sine u du. The integral of sine u will be minus cos u, evaluated as we range from 0 to pi. So plugging that in, we're going to have -3/2, pointing that negative out. Cos u from 0 to pi, that'll be cos pi minus cos 0. And think of the unit circle. Cosine of pi is -1, and cosine of 0 is +1. So we're going to get -1 minus 1. -3/2 times -2, and the answer after all that is just 3. Our next example is the integral from 1 to 2 of x squared over the square root of x cubed plus 1. We want to identify what u is going to be. If u is x cubed plus 1, the derivative is 3x squared. Is there a multiple of 3x squared in the numerator? There is. So that's indicative of a strategy that may work for us. So letting u be x cubed plus 1, the derivative of, with respect to x of u is the derivative with respect to x of x cubed plus 1. So du dx is 3x squared. And with my process, I'd like to solve for dx. So du is 3x squared dx. Du divided by 3x squared is dx. That's how that's going to sub out. And notice the x squared will cancel that x squared. Root x cubed plus 1 will become root u, and then we have to worry about the endpoints. So how do I change x equals 1 and x equals 2 to values for u? So if x is 1, u is x cubed plus 1, 1 cubed plus 1 is 2. And if x is 2, 2 cubed plus 1, 8 plus 1, u would be 9. So my new endpoints are 2 to 9. X squared stays there, root u, du over 3x squared. is what we have to work with. And you'll notice the x squareds cancel nicely, and we have an integral just in terms of u, which is what we're looking for when we do u substitution. So pull the 1/3 out in front after the x squareds cancel. We get 1/3 integral from 2 to 9 of 1 over root u du, which is 1 over u to the 1/2, or u to the negative 1/2. And then we remember our favorite power rule, integral of x to the n is x to the n plus 1 over n plus 1. U to the negative 1/2 plus 1 over negative 1/2 plus 1. That's u to the 1/2 over 1/2. Now divided by 1/2 is the same as timesing by 2, so it'll be 2/3 u to the 1/2, or 2/3 root u. Then we're going to plug in a value of 9 and a value of 2, so 2/3 root 9 minus root 2. Root 9 is 3, so 2/3 of 3 minus root 2, which is good enough for us. Our next question is the integral of 7x over x minus 4. Now this one's a little different. We're going to let u equal x minus 4, but we're going to have to do a substitution. If u is x minus 4, the derivative with respect to x of u is the derivative with respect to x of x minus 4. So du dx is 1, which means du equals dx. So dx becomes du, x minus 4 becomes u, but what about the x up there? How can we turn x into a function of u? And we just use this piece up here. If u is x minus 4, u plus 4 has to be x. So solving for that x, we can then substitute 7x becomes 7 times u plus 4. Again, x minus 4 is u, dx is du. Multiply that 7 times u plus 4, they'll give us 7u plus 28. Now we can write this as a sum of two integrals, 7u over u du, 28 over u du. 7u over u, of course, is just 7. And we can break that up into two integrals, as I said. And we can pull the 7 out, we can pull the 28 out if we're interested. The integral of du is just u, and the integral of 1 over u is natural log of absolute value of u. But what is u? u is x minus 4, so this will be 7 times x minus 4 plus 28 times the log of absolute x minus 4 plus c. Which is a correct answer, but we can actually make it a little bit cleaner. If I distribute the 7, I get 7x minus 28. This answer, again, is correct, but I can make it cleaner, because negative 28 is a constant. Negative 28 plus any arbitrary constant is still any arbitrary constant. So we can think of the negative 28 getting absorbed into c. So a slightly better answer would be 7x plus 28 times the natural log of the absolute value of x minus 4 plus c. Here's our next problem, and I'm going to do it two ways. Tangent of 5x over 9 times the cos squared of 5x. The way most students will do this will be to convert everything into sines and cosines. So that'll be my first strategy. So tangent 5x is sine 5x over cos 5x. So I need tangent 5x divided by 9 cos squared 5x. So you'll notice I've rewritten tangent 5x as sine 5x over cos 5x. There's the tangent 5x. Divided by 9 cos squared 5x over 1. And when you divide fractions, you invert and multiply times 1 over 9 cos squared 5x. So sine 5x times 1, sine 5x on top, 9 cos squared 5x times cos 5x will give us 9 cos cubed 5x on the bottom. And rather than integrating this, we can integrate this, and we can find a u that's relatively easy here. But it requires some significant algebra. So we want to go ahead and take a look at that. So rewriting this with algebra, we have integral of sine 5x over 9 cos cubed 5x, and our u will be cos 5x. The derivative with respect to x of u is the derivative with respect to x of cos 5x. The left-hand side is du dx. The right-hand side, derivative of the cos of something minus the sine of 5x times, chain rule, the derivative of 5x. It'll be minus sine of 5x times 5. So multiplying both sides by dx, du will be negative 5 sine 5x dx. And then to solve for dx, multiply by dx, and then divide by the negative 5 sine 5x. So that'll be dx. Notice it'll cancel the sine 5x here. This is going to be u cubed, right? Cos cubed 5x, u cubed with a 9. the integral becomes this. Cancel out the sine 5x's, pull out a negative 1/5 times 1/9, so that's what, negative 1/45. All that's left is 1 over u cubed du. So we know that u was cos 5x. Now we've got to do the integral of negative 1 over 45, 1 over u cubed du. But 1 over u cubed is u to the negative 3. And then we use our power rule, integral of x to the n plus 1 over n plus 1, u to the negative 3 plus 1, u to the negative 2 over negative 2, plus c. 45 times 2 is 90, negative over negative is positive, so 1/90th u to the negative 2 plus c. But u to the negative 2 means 1 over u squared. 1 over 90 times 1 over u squared plus c. But what is u? u is cos 5x. So we have 1 over 90 times 1 over cos 5x squared plus c. Perfectly good answer. The notation that we typically use, though, is cos squared of 5x. So here's a slightly cleaner looking version of that same problem. So that was doing everything in sine and cosine. But if you look at it another way, the problem can be solved a little bit more quickly. But before I do that, let's rewrite the over cos squared as secant squared. Remember, secant squared is 1 over cosine squared. So just to kind of look at it another way. All right, so back to the problem. What is another way for me to do this? I'm going to solve it with the u substitution without converting to sines and cosines. I know the derivative of tangent is secant squared, and secant squared is what we have here because we have cosine squared downstairs. So watch this happen. U is tangent of 5x. The derivative is secant squared of 5x times 5, thanks to the chain rule. So solving for du, multiplying by dx, du will be 5 secant squared 5x dx. And du divided by 5 secant squared 5x is going to equal dx. So this is u. And what about over secant squared? If secant squared is in the bottom, secant squared is 1 over cosine squared. That's going to move the cosine squared to the top. So divided by secant squared is the same as multiplied by cosine squared. So we get cosine squared 5x over 5 du equals dx. And you'll see this will get done much faster this way. U is tangent 5x. 9 cosine squared 5x we're leaving alone. Dx here, cosine squared 5x du over 5. The cosine squareds go away. Notice 9 times 5 downstairs, 45 downstairs. So 1 over 45 comes out, and all that's left is u du. Recall we had the 45 in the other strategy. Integral of u to the first is u squared over 2. So we have 1 over 45 times u squared over 2. 45 times 2 is 90. So 1/90th u squared plus c. What is u? Tangent squared 5x. And we're able to get this whole problem done on one slide as opposed to several slides that we had for the sine and cosine method. Now the answers don't look exactly the same, but you can show that they're the same using trig identities, and I encourage you to do that. Okay, one last question for us to do. Integral of x times the cube root of x minus 5 dx. Another sort of tricky problem. We're going to let u equal x minus 5. The derivative with respect to x of u is the derivative with respect to x of x minus 5. So du dx is 1. Du equals dx. So I have cube root of u, and I have du, but I still have this x hanging around. But if u is x minus 5, I can solve for x and recognize that u plus 5 is x. Now let's make those substitutions. Integral of u plus 5 times the cube root of u, x minus 5 is u, du. Distribute u times cube root of u plus 5 times cube root of u, du. But cube root of u is u to the 1/3, and u is u to the first. So u to the first times u to the 1/3, we add the exponents, that'll be u to the 4/3 plus 5u to the 1/3. So we'll need this, we'll need our u value, and we'll go from there. Using our power rule, integral of x to the n is x to the n plus 1 over n plus 1. But I'm going to break this up first. U to the 4/3 plus integral of 5u to the 1/3. Pull the 5 out in front to make that a little simpler. All right. 4/3 plus 1. 4/3 plus 3/3 is 7/3. U to the 7/3 over 7/3. Similarly, 1/3 plus 1, 1/3 plus 3/3 is 4/3. U to the 4/3 over 4/3 using our power rule here, integral of x to the n dx, x to the n plus 1 over n plus 1. Again, 4/3 plus 1, u to the 7/3 over 7/3, 1/3 plus 1, u to the 4/3 over 4/3. Dividing by 7/3 is the same as multiplying by 3/7. Dividing by 4/3, multiplying by 3/4. 5 times 3/4, 15/4. So there's our 3/7, u to the 7/3, plus 15/4, u to the 4/3. What is u? X minus 5. Replace u with x minus 5, and I would argue that is good enough. So we'll take a final answer of 3/7 times x minus 5 to the 7/3 plus 15/4 times x minus 5 to the 4/3 plus c. And that will conclude this lesson.